Hello students, in today's video we are covering two more criteria related to triangles and also we are covering exercise 7.1. So let us start. ASA congruency rule of triangles. What is this ASA congruence? Means two triangles are congruent if two angles and the included side, that means the common side, included side of one triangle are equal to two angles and the included side of the other triangle. This is very simple. Okay, criteria are very simple to understand also. So I will show you through a figure. Suppose we are taking two triangles. This triangle is triangle ABC. One more triangle. That triangle's name it is triangle DEF. So these are the two triangles. In these two triangles, any of the two angles here, two angles and their common side, that means included side, that angle should be included in that side. So suppose if we are considering this angle and this angle, that means angle B and angle C, then included side means BC. No, BC is the included side in that two angles. Okay. Similarly, the same way, corresponding angles in the next triangle if also equal, then we can say these two triangles are congruent on the basis of this congruency rule. Okay, so angle B is equal to angle E, corresponding angle C is equal to angle F. These two are corresponding, and included side it is BC here included side it is EF. Suppose this is 5 centimeter and this is also 5 centimeter. So we can say these two triangles, triangle ABC is congruent to triangle DEF by which criteria? ASA congruency rule. By this is congruent. Okay. Now come to the next congruency rule, AAS. Any two sides of one triangle, if it is equal to the other two sides of that other triangle. For example, first of all we will read this. Two triangles are congruent if any two pairs of angles, look, two angles are here, two angles and one pair of corresponding sides are equal. That means let the two triangles, triangle ABC and triangle DEF. Here what saying? Two pairs of angle, any two pairs, suppose this one and this one, that means angle B and angle C are equal. So they are corresponding angles here, angle B and angle E, they are corresponding, they are equal. Angle C and angle F, they are equal. So two pairs of angles equal. Now any one pair of corresponding side, it is not compulsory. Here included side it is compulsory because S should be, the side should be in the middle. Side should be in the middle. That is compulsory. That is there in the criteria. Here angle side, if any one of the side if we are taking, no problem, we are not taking this one. If we are taking this one, then this criteria is applicable there, so we are avoiding this. And any other two sides are there, any one of the side we are taking. Suppose if we are taking this side, then the corresponding side is this. Suppose this is 4 centimeter, so this is also 4 centimeter. That means these two are equal, these two sides are equal, then these two triangles are congruent. Triangle ABC is congruent to triangle DEF by which criteria? AAS. Okay. Now if you are thinking, can we write this like this way as AA? No, this is wrong. This is wrong. Which way it is given? Same criteria only we have to use. Okay, the letters here and there we can't shift. Okay, 5 criterias only provided, that 5 criterias only we have to use. With the help of that 5 criterias only we can prove the congruency of triangles. Okay, we can't shift the letters here and there. Okay, so if AAS, that means 2 angle and 1 side, here also 2 angle and 1 side itself. No, like that way maybe you are thinking, but it is not correct. Okay, same way, which way provided, same, in the same order we have to take angle, angle, side. Okay, so these two criteria are also included in the first exercise. Now total five criteria are there. We go with three the criteria. Which are the 3 criteria we already learned? First one it is SAS criteria. Then we learn ASA criteria. Then the third one AAS criteria. Okay, now how to apply this? Application level is more important. This is also given in our textbook. When we are reading this, we will understand this. Okay, rather than this, which is more important? Application level is important. Okay, so let us look that. Here is one example question. This is the figure provided, and very short I written the question here. What all things it is provided? Let us see. Line segment AB is parallel to line segment CD. That means these two lines are parallel. It is given. O is the midpoint of AD. So AB is the line. This one is AD, and this O is the midpoint. So if any line segment, if we are taking suppose AD, and if we are saying O is the midpoint, so what we have to understood, these two line segments are equal. No, that means the length of AO equal to the length of OD. Why? Because this is the midpoint. Similarly here AD's midpoint is O, so that why AO equal to OD. Okay, then so they given O is the midpoint of AD, that much only they given, but we have to understand like this way also. It is understood in this point, this is understood, these two line segments are equal. Okay, now what we have to prove? 2 cases we have to prove. First one, triangle AOB. Where is triangle AOB? Triangle AOB, that means this triangle. Okay, and triangle DOC. These both triangles are congruent. That what we have to prove. Secondly, we have to prove O is also the midpoint of BC. Here we said AD's midpoint is O. Okay, they not said BC is also the midpoint is O. They not said that we have to prove. Okay, so let us start. Whenever we are starting any of the proof, so what all informations they provided, that we have to write first. Okay, so here we are starting the solution. What all informations they given, that we have to write. So AB is parallel to CB given. Okay, this is given. Then O is the midpoint of AB, which means AO is equal to DO. Okay, this matter is also given because they given this statement. No? So from this we will understood this. Okay, then any other information given? No, only 2 information given. Now let us start the proof. Okay, so before that, to prove whatever the things we have to prove, that also we can write, no problem. So to prove, what we have to prove? So for these 2 we have to prove. So first one we are taking triangle AOB is congruent to triangle DOC. This we have to prove first. Okay, now we are starting the proof. Okay, so whenever we are proving the congruency, mainly we need 3 statements we needed, because to represent the 3 criteria, so 3 letters needed. So before that, first itself, which 2 triangles we are considering, that we have to write. So in triangle AOB, and because these 2 are congruent, we not yet proved. Okay, we are going to prove only. So here we have to consider the 2 triangles, this and that. So triangle DOC. So we considered this triangle and this triangle, we considered. Okay, now what all informations they given, it is helpful to us that we have to check. Okay, so in this triangle we can say AO is equal to DO. AO is equal to DO, which is given. Okay, then we know this angle and this angle is equal. What is the reason? Vertically opposite angle. Okay, so that also we can write angle AOB is equal to angle DOC. What is the reason? Vertically opposite angles are equal. Okay, now any other information we are getting from this? See, this is the clue they given. AB parallel to CD. These two lines, if it is parallel, then we can take this and this, they are equal. No, why? Because if parallel lines are passing, then we can take these two are what? Alternate angles. And if these two lines are parallel, if we know they are parallel, then these alternate angles are equal. No, so here we can take angle A and angles D, they are equal. Angle A and angle D, they are equal. What is the reason? Alternate angles are equal. Why alternate angles are equal? Because they given these two lines are parallel. That way. Okay, so we can take here angle BAO is equal to angle CDO. What is the reason? As AB parallel to CD, they given that as AB parallel to CD, so alternate angles are equal. Okay, now here we got three conditions. Okay, angle, side, angle. Okay, angle, side, angle, and here also angle, side, angle. So we can say therefore the same two names again we have to write. Triangle AOB is congruent to triangle DOC by angle, side, angle criteria. Two angles and included side we take. Okay, so angle, side, angle rule, congruency rule. Because of this, these two are congruent. So first part we proved. Okay, now the second. O is also the midpoint of BC. Now in this question what we know, these two triangles are congruent. Now we are proving the second case. So second, what we know, triangle what is the name? AOB is congruent to triangle DOC. Proved. Okay, this is already proved. If any two triangles are congruent, then their corresponding sides and corresponding angles are equal. No? So here, see, this side is equal, that we know. So which two sides we not said? The CO and OB's case we not said. AB and CD's case we not mentioned. Actually they are also equal because the triangles are congruent. So here we needed O is also the midpoint of BC. So the line BC we have to take. We know these two sides are also equal because the triangles are congruent. No, so these two sides are also equal. What is the reason? Because of CPCT, corresponding parts of the congruent triangles are equal. Because of that reason, these two sides are also equal. So you just look, if we are taking the side CB and here is O, CO and OB, are equal, that we know. So definitely O is the midpoint. No, O is the midpoint. Okay, so hence we can prove that. So here this is already proved thing. So next we have to write this triangle's side. It is BO is equal to CO. How? By CPCT. CPCT, they are equal. Okay, so therefore O is the midpoint of the line segment BC. Midpoint of BC. Hence proved. Both the cases we proved. This is an example question. I hope you understand. Exercise 7.1, first question. In quadrilateral ACBD, AC equal to AD, AC equal to AD, and AB bisect angle A. That means AB, this line is bisecting this angle A, equally dividing. That means the measurement of this angle and this angle is equal. That is the meaning of bisection. Bisection means equally dividing. Angle A is divided equally. Okay. And what we have to prove, show that triangle ABC. Triangle ABC. That means this triangle and triangle ABD. Triangle ABD. These two triangles are congruent. That's what we have to prove. Okay. So let us start. So solution, we are starting. What all things, what all informations they given, that we have to write. First of all, AC equal to AD given. Then AB bisect angle A. The line AB is bisecting angle A. So which means in this triangle, angle CAB, and from the second triangle DAB. These two angles are equal. From this statement we understood that. Okay, so we have to write that angle CAB is equal to angle DAB given. Okay, now to prove, what we have to prove? We have to prove these two triangles are congruent. Triangle ABC is congruent to triangle ABD. This we have to prove. Now we are starting the proof. Proof. In triangle, we have to consider first, in triangle ABC and triangle ABD, two informations they given, this and this. Okay, one side and one angle they given. Okay, so that what we have to write first. So from the top triangle first, AC is equal to AD given. Then angle CAB equal to angle DAB given. That also given. So two cases we got. Now one more we needed. No, in these two triangle, the side AB, it is a common part. No, common. That line segment is common to the upper triangle and the bottom triangle. So we can take that. So this line is equal. No, for both. So we can take AB equal to AB. The line segment AB is equal for both the triangles. What is the reason? Because that is common. Okay, so here this is one side and this is one angle and this is another side. So with the help of which criteria we can say these two triangles are congruent? By SAS. So we have to write that. So therefore triangle ABC, this and we have to remove, and there we have to apply the symbol, congruency symbol, congruent to triangle ABD by SAS congruency rule. Okay, So this what we have to prove. So that is over. Now one more question they are asking, what can you say about BC and BD? Now where is BC and BD? This is BC and this is BD. What we can say about these two sides? That are also equal, no? Why? See, with the help of these three, side, angle, side, we said these two triangles are congruent. If once we proved it is congruent, then which sides and which angles we not mention, that are also equal, no? So here they are asking, what about these two sides? That two sides are equal. What is the reason? CPCT. So that also we can write, that two are equal. BC and BD, no? So this triangle's side is BC. So here we will write BC equal to BD. Reason it is what? CPCT. So hence proved. This is the first question. Now let us start the second question. ABCD is a quadrilateral. ABCD. It is a quadrilateral in which AD equal to BC. AD equal to BC. They are equal, they said. Okay, they are equal. And angle DAB. Where is DAB? DAB. That means this corner. Angle DAB and BAC. Okay, these two corners are, our angles are equal. Angle DAB. Once again, DAB, that means this corner, and CBA, that means this corner. Okay, that two angles are equal. These two conditions are given. Okay, now what we have to prove? We have to prove triangle ABD. Where is triangle ABD? ABD. That means this triangle. Okay, and triangle BAC. That means this triangle. So if we are taking the triangle, so in this way. In this way. Okay, this part we are not using. This part we are not using in quadrilateral. This portion we are not using. So this is the triangle. This part fully we are taking as one triangle, and this part fully we are taking as one triangle. So that two triangles we have to consider. So let us start. So the information we are writing in solution. In solution, AD is equal to BC given. Then angle DAB is equal to CBA. It is given. Okay, and what we have to prove, it is here. So we are writing proof. Proof equal to, in triangle, which two triangle we are considering, that we have to write. We are considering these two triangles because that two triangles are congruent. That what we have to prove, no? So in triangle ABD and triangle BAC, we considered. What all informations we know in this two triangle? This side and this side is equal, and one angles are also equal. So one side we got, one angle. Okay, side and angle. Now we just look this AB. It is the common side, no? That is common for both the triangles. So that is also equal. So here again we got side. So side, angle, side. Side, angle, side. So on the basis of that criteria, very simple way we can say these two triangles are congruent. So let us write. So AB equal to BC given. Then angle DAB is equal to angle CBA given. Then these two are given. Now the third condition we are writing from our knowledge. Okay, we know this is common. Okay, so that what we are writing, AB, the side AB for this triangle and the side AB for this triangle. Just look, here also AB, here also AB. So AB equal to AB. What is the reason? Common. They are common. So therefore triangle ABD is congruent to triangle BAC by SAS criteria. Okay, so first part we proved. Now come to the second. BD equal to AC. BD, where is BD? BD, that means this third side. This one is equal to AC. Yeah, that are equal. What is the reason? Because already we said the triangles are congruent, so their corresponding sides and angles are also equal. So here they ask the side, so we can say second part we can say like this way. BD is equal to AC. What is the reason? CP. Now come to the third question. Angle ABD, that means this angle, and BAC, BAC, that means this angle. Both are equal? Yeah, both are equal by CPCD. So that also we can write the third question. Angle ABD is equal to angle BAC by CPCD. Hence proved. This is the solution for the second question. Third question. AD and BC. AD and BC are equal perpendiculars to a line segment AB, which means AD and BC, they are perpendicular to the line AB. AB is the line, BC and AD, they are perpendicular, which means here is 90 and here also 90. They said the word perpendicular, we understood that here the corner it is what, 90 degree, which means these two corners are equal. Everything it is understood from this single word, perpendiculars. Okay, so segment. Then what we have to prove, that is the thing they given. Now what we have to prove, CD bisect AB. CD bisect AB. That means equally it is bisecting. Bisection meaning it is what? These two sides are also equal and these two sides are equal. Then only the bisection, no? So that what we have to prove. Okay. Now what is the logic behind this? Okay, that what we have to think. How we can prove? See, these are the given statements. Now how we will reach to the answer? First of all, I am just saying the logic. If we are able to prove these two triangles are congruent, then their other sides are also equal. No, suppose these two triangles are congruent. So this triangles this side and this triangles this side is equal by CPCT, no? Then similarly this side is equal to this side because of what? CPCT. Here we have to take CD bisect. CD is this. CD is bisecting AB. That what we have to say. So if the sides are equal, then definitely that is the bisector, no? Yes. So like that way we can prove. First we have to prove the triangles are congruent. Okay. So these things are not given. Okay. Now we have to think which criteria we can use to say these two triangles are congruent. Okay, so let us think about that. One side and one angle with us. Okay, these two angles are equal because perpendicular means 90 degree, same to same measures. Then AD is equal to BC, they provided. So one angle and one side with us. Okay, now anything we will get from this figure, that what we have to look. Okay, very closely just look the figure. Yes, we will get this. Here we will give the name O. These two angles are equal. What is the reason? These two angles are vertically opposite angles, no? So that are equal. So here we got one angle here and here also another angle, and this is the side. So the side is not included. Okay, the side is not including these two angles. No problem. Criteria is available. No. What is the criteria? AAS. Okay, with the help of this criteria, we can say these two triangles are congruent. Okay. So here in solution we can write what all things it is given, we will write that first. AD is equal to BC and perpendicular. Okay, so which means these two corners are 90 degree. That also we can write. Angle DAO is equal to angle CBO. Okay, this we understood from the question. Now proof we are starting. Proof, which two triangle we have to consider? These two triangles we have to consider. So triangle, in triangle OAD and triangle OBC. Okay, now the corresponding parts we have to write. We can take first angle, we can take angle, which one we can take? This one. Angle DAO is equal to angle CBO given. Okay, then this angle we will take, vertically opposite angle. Angle DAO. Next one, DOA is equal to angle COB. This two, it is not given, that we find out what is that vertically opposite angle. Vertically opposite angles. Vertically opposite angles are equal. Okay. Now the side we will take. DA is equal to BC or AD equal to BC. No problem. Given. Okay. So here three statements we got. This is angle, this is also angle, and this is the side. So by AAS criteria, so triangle OAD is congruent to triangle OBC by AAS criteria. So the proof it is over. But in question they not ask these two triangles are congruent or not. That they not ask. Okay, their demand it is CD bisect AD. That is their demand. So we have to answer to that also. Okay, so here we can take the two sides. Okay, CD bisect AB. So AO is equal to BO. AO is equal to BO. What is the reason? CPCT. So we can say no. We can say CD is bisecting AB. Okay, so that's all.